Right there, we're going to graph logarithmic functions. Yesterday, we kind of figured out what they were and how they worked a little bit. Now we're going to see what the graphs look like and kind of graph them. And remember, when you see the word graphing, that means it's an easy day because we're just going to use all our gestures and graph these things so easily once you see the parent function. So here they are. All right, parent graphs. This is the most important slide because if you know the parent graphs, you can graph anything. Two things here to remember. First of all, logs and log functions and exponential functions are inverses of each other, which means your x's and y's switch. So look at this first picture right here. The blue graph represents the exponential function that we graphed the other day. It goes through 0, 1 on the y-axis. It's increasing. It's going left to right. It's going up. It goes left and right forever. The x-axis is an asymptote. Now, inverse-wise, remember it's a reflection across the line y equals x, but everything just switches. Now your y-axis is an asymptote. Instead of going through 0, 1, it goes through 1, 0. It doesn't go left and right forever. It goes up and down forever. Everything is backwards with its. Everything is reversed or interchange with your exponential versus your logarithmic graph. Now, that's the case if it's exponential growth or if your base here is bigger than 1. You know, that's kind of like growth also. Now, if your b is less than 1 or your exponent is less than 1, you get exponential decay. Still goes through 0, 1. It's going down instead of up because it's decay. Look what happened with our log graph. Look at the red graph here. It's also decreasing, also going down when your base is less than 1. Still goes to 1, 0. It's just going down. And again, instead of the x-axis being the asymptote, the y-axis is the asymptote. Everything just interchanges with your x's and your y's, which you should have predicted. So your graphs today, your log graphs, are either going to look like this one. Let me change colors here. They're either going to look like this one right here, if your base is bigger than 1, or it's going to look like this right here if your base is less than 1. All right, so no big deal. That's what the parent functions look like. We can do our gestures, and I'll remind you those tomorrow, and we'll be good to go on these things. All right, let's look at a couple. I think I have 3 examples. First one says log base 3 of x in the graph. Now it shows 3 points. I put a star above this first point because you need to pick that point every time. You need to put 1 in for x right there because no matter what the base is, 3 to the 0 powers at 1 is. That will always be 1, 0. That's why, because anything to the 0 power is 1. That's why I like that point so much. So I graphed it right there. I picked 3 because that's what the base was. So it gave me log base 3 of 3. Hello, 3 to what power is 3? The first one. And I chose 9 because 3 to the second power is 9. So I always pick numbers that I can, make work real easily. And I just connected the dots, la, 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 and there's my graph. Exactly what it should look like. No big deal. The second one, I want to show you one where the base is less than 1, which means the graph's going to go down instead of up. Look what I started again. First point I picked, still picked 1, 0, because if you do this, no matter what the base is, if you have a 1 right there, 1/2 to the 0 power is 1. So that 1, 0 is going to be a point I'm going to pick every stinking time. Now, the reason I picked 2 is because the 1/2. I know if I flip 1/2, it becomes 2. And the way you flip something is you raise it to a negative exponent, which I did. So I'm really thinking 2 instead of thinking 1/2 here. 2 goes into 4, 2 squared, so I did -2. 2 goes into 8. 2 to the -3, or 2 cubed is 8. -3 because I had to flip the 1/2. Connect the dots, la la la. And there's your other graph. Okay, it just goes down just like we thought it would. Okay, one more where you got some shifts and things. Let's look at the last one. Like the last one says, graph y equals log base 2 of x plus 3 plus 1, and state the domain in the range. Now, this has a lot of stuff. This is a regular graph. It's bigger than 2, so I know the graph's going to go up like this. The only difference is it's going to be shifted left 3 and up 1. I'm going to go ahead and do this. One thing I know for sure is my asymptote is usually the y-axis. Because it's been shifted left 3, this line I'm drawing right here to -3, that's my new asymptote. My graph will not touch that line right there, will not touch the asymptote. So that's my new, basically, y-axis, but it's really just the asymptote. So I'm going to act like at first I'm actually just doing this. I'm going to forget the shift for a second, and I'm just going to graph this right here, log base 2 of x. So I did the same thing here. I did 1, 0. I'm going to do this real lightly. 1, 0 is right here. 2, 1 is right there. 4, 2 is right there. All right, so what's going to happen with those points, though, because I see the shifts, it's going to be shifted left 3 and up 1. So I'm going to take each point, take this first point, which is right here, go left 3, up 1 to right there. This one's going to go left 3, up 1 to right there. The last one's going to go left 3, up 1 to right there. Now you can connect the dots. La, 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 and there's your graph. Okay, so all I did is I act like all this shifting wasn't there, and then I shifted it. Asymptote definitely gets shifted first, though, like we did with the exponents the other day. Okay, last thing it says is domain and range. The domain, notice it does not touch the asymptotes. The domain would go from -3 to forever, left to right. The range, it is going up and down forever. As you can tell, it's going up, down forever, up forever. So it's all reals, or negative infinity to positive infinity for your range. All right, that's as tough as it gets. We'll work on some of these tomorrow like we always do. See you then.